Alright, in this video we're going to talk about finding the derivative using the definition of the derivative. And from our formula booklet, we are told this information here. The derivative of f of x is equal to y as f of x dy over dx, which is one notation. Df of x over dx is another notation. Derivative of y with respect to x is another notation. Or we say y prime or f prime of x is equal to this definition here. Alright, and so now we want to use the definition to find the derivative. Now, using the power rule, we know the answer should be 6x. But we are told we have to use the definition, so we have to use this. Sometimes it's also called by first principles. That's another way it may be asked. So, in order to do it, we have to be good with our notation. Do not get sloppy with our notation. The derivative of f of x is equal to the limit as h goes to 0 of 3x plus h squared, because that's what my x value is, minus 3x squared. All of that is over h. And then limit h goes to 0. Don't forget the limit is 3. If I multiply this out, that's x squared. It's 2xh, so plus 6xh plus 3h squared minus 3x squared all over h. And I can then cancel the x squares. And if I put h of 0 in here, then everything cancels out because there's 0 on the bottom. And, well, everything doesn't cancel. I get 0 on the bottom, which I can't do. So what do I have to do then? I go to limit as h goes to 0. I'm going to factor out an h from the top, which gives me 6x plus 3h over h. Conveniently, the h's now cancel, and I'm left with the limit as h goes to 0 of 6x plus 3h. Well, if h goes to 0, well then that computation is 0. I take the limit, I end up with 6x. And so the derivative is 6x, which is what we knew already from the beginning. Trying it with this one. Find f prime x, and I want to use first principles because that's what this lesson is all about. You should pause the video yourself and try it, your own. Pause it. I'll help set it up if you're not sure. It's limit h goes to 0 of x plus h cubed minus x cubed over h. So pause it, do this expansion yourself, and then come back and see what I've got for you. Keep on going here. I've expanded it out. I've canceled out the x cubes. I'm going to factor out an h, so I'm still taking the limit. Don't forget your notation. Factor out the h, 3x squared plus 3xh plus h squared over h, and again the h's cancel, which is a common thing that happens when we take derivatives with polynomials and with first principles. So I'm left with the limit as h goes to 0 of 3x squared plus 3xh plus h squared. If I take the limit, which means I plug in 0 here and here, it means I end up with 3x squared using first principles, which should make sense because the power rule says we pull the 3 down, subtract 1 from the exponent. This one here, I want you to try yourself using the binomial theorem. And when you're done, you know you should get 6x to the power of 5, but I want you to use the binomial theorem and the definition. All right, last question I'm going to do with you. We're given this function here, square root of x. Find the slope of the gradient. Well, the slope is, this is a typo. It should be the slope of the tangent at the point 4, 2. You guys have it, tangent, in your packet. Make a quick sketch to illustrate what's going on. Well, if I'm going to do a quick sketch, I know here is my graph of square root of x. Here's the point 4, 2. I want the slope of the tangent. Here is the tangent line. I'm looking for the slope at this point. Okay, so if I'm going to do that, I need to find the derivative at 4. So in order to do it, I'm going to use first principles all today. Limit as h goes to 0 of x plus h square root minus x all over h. And this is going to be my derivative of x. Once I find the derivative, then I plug in 4. Now, this one's a little bit different, and so the trick I have to do here is I have to rationalize the numerator. And this will do some magical things to my equation to get rid of certain aspects to allow me to take the limit. So when I multiply by the conjugate, h goes to 0, I get x plus h minus x when I multiply these two here, because the middle terms cancel out. And the bottom will be h parentheses x plus h plus square root of x. Well, I can see I can subtract x and here. And so then I have h over h. Those cancel as well. And I end up with the limit as h goes to 0 of 1 over square root x plus h plus square root of x. If I take the limit as h goes to 0, I make this 0. I have 1 over root x plus root x, which is 1 over 2 root x. That's the derivative. I want to find the derivative at 4. I plug in 4. It's 1 over 2 square root of 4, which is 1 over 4. So what this means is the slope of this tangent line here, that slope is 1/4. The final problem, I'm going to let you do this one on your own to derive the power rule using the definition of the derivative and the binomial theorem. Good luck.